Next, if we do the integral of the total external force by dt is equal to the integral of m a cm dt, and since we say that m is a constant in time, so we may take it outside the integration. So this is the m of the integral of a cm dt. But from the definition, we have that this is m of d v cm by dt times dt. So we have that this is equal to the m of d v cm, which equal to the m times the delta v cm. Okay. The left side of the equation is the impulse. Okay, this term is the integral of f dt, which we have defined this before as the impulse of the system. Okay, it's the impulse of the external force that exert on the system. But we can see that this m times delta v cm is equal to the change of the total momentum, right? Because mvcm is the total momentum, and we assume that m is a constant. So if we multiply the total mass with the change of the velocity of the center of mass, it will equal to the change of the total momentum. So we have again we can call this the impulse momentum, the impulse momentum theorem. For a system of particles. For a system of particles, we can see that we have the same mathematical expression of the impulse momentum theorem, that this is an impulse from the external force and the change of the total momentum. So the behavior of the system of particles is very similar to the behavior of a single particle if we explain it in terms of the center of mass. So we have the center of mass of a particle having combined mass m moves like an equivalent particle of mass m would move under the influence of the external force on the system. An interesting example is that when there is no external force, so if the net external force is 0, so it means that the impulse is 0, and it means that the change of the total momentum is 0. So we have that the total momentum of the system is a constant. Okay. And since P total is MVCM, so we have that MVCM is a constant. It means that if there is no external force on the system, the total momentum is constant and the center of mass moves with a constant velocity. And this is very similar to the situation for a single particle.